Hi class, this week's presentation is going to revisit the three main topics that we are covering in Teamwork 4, Lab Assignment 4, namely image maps, audio, and video. So we have already briefly discussed all three of these this week. We're just going to go back and recap the information that we've seen and what we've learned about these three elements, and we're going to look at them in some more detail. So we start with image maps. Uh, Websites need to be navigable. You need People need to be able to navigate websites, and image maps are just one tool that can help you with that task. We can use navigation menus, or we can use navigation bars. Um, the navigation menus and bars may have clickable image regions, also known as hotspots, that can take the user to different locations, for example, various web pages, when you click on them. And this is just like the clickable image or the button panel that we have already seen. Many image maps may be designed to change in appearance with the help of CSS. You can achieve effects like you can light them up, you can change their color as you hover the mouse on top of them, or over a particular hotspot of the image. Um, and one other way to do this is with the help of JavaScript. So we're getting closer and closer to looking at JavaScript. I just wanted to mention today that it is one way of customizing your menus and bars. So the image map components are an IMG element and a map element. The IMG element is going to be a GIF, a JPEG, or a PNG, and it will identify an image that will have a number of clickable areas. The map element contains the coordinates and the URL information for each clickable area in the image. Okay. The map element makes it possible to specify different clickable regions within a single region. In order for us to be able to accomplish this, we need to know how the coordinate system works. Please note the coordinate system for creating image maps, or pretty much all coordinate systems in computer science are set up this way. The 0, 0, or the origin of the system is located in the top left corner. Okay, so origin is in the top left of the image, and the y-axis goes downwards. We use this information when we specify the x and y coordinates of the hotspots within the image. What you're seeing here down at the bottom is an example of a clickable region being defined, a rectangular one. So this is a rectangular region. We specify the top left position with the help of x and y coordinates, and the bottom right position with the help of x and y coordinates. Okay, the map element, like we said, allows identification of multiple hotspots in the image by specifying separate area elements for each of the hotspots. And then the area elements are enclosed within the map element. So what we're seeing here is the syntax for creating the map element. We give it a name and we create areas. We can create as many areas as we need. The area element, oops, the area element's attributes describe the shape and the location of the hotspot and the URL to link when the hotspot is clicked. So in this short example here, we set the shape to rect. This could be circle, or it could be polygon, or poly. So if you have a triangle, for example, this is going to be set to poly because we don't have a triangle shape. And We define the coordinates for rectangles. We need the top left and the bottom right corners. And of course, the most important part down at the bottom here, we need to tell the computer where exactly we want the browser to go when we click this part of the image. In addition, we must declare an image element to specify the image being mapped, and we need to add a useMap attribute to this image element. So the correct syntax for that would be img source, specify the source. In this case, we're assuming the shapes GIF file is in the same folder where our main HTML page is, and we'll link it with the correct map using the map name here. So please note that the useMap attribute must match the name attribute of the map tag, and it's preceded by a pound sign. As we said for the coordinates, if it's a rectangle, we define the corners of the rectangle. We use those to specify the coordinates of the rectangle. For a circle, we use the location of the center along with the radius of the circle. And for a polygon, we use the coordinates of each one of the vertices. And we list those in order. Here's an example. We could create an image from the image that's shown on this slide. Each geometrical figure needs to be clickable. The units are in pixels. So here's an example of how this can be done. For the circle that you see, the green one in the middle, I'm assuming the radius is 17 pixels. The location of the center is at x equals 106, y equals 18. For the blue rectangle, the top left corner is at location 14 and the bottom right at 6032. And for the triangle at the end, the red one, which happens to be defined as a polygon, the coordinates of the vertices are 170, 150, 32, and 190, 32. So the triangles are treated as a polygon. You pick one of the vertices and you go in order. So you list the vertices in order. And this is how we translate that. This is the middle step, if you will. So the syntax here outlines what you need to include in your HTML file in order for this to work. It isn't complete yet, but on the next slide we can see the final version of it. So we have translated our pseudocode, if you will, to actual HTML code that we can use for this image map. Discovering image coordinates. I know some of you have had difficulties with that. For the most part, we're going to try and keep things simple. In this class, usually when you're creating an image, you can pretty much, knowing what the size of the image is, you should be able to guess where the vertices are located. So you use trial and error. You guess the coordinates. If you guess wrong, if something isn't working quite right, you take another guess. Now there are some tools that can help you with this. Image maps can be created with the help of an image map generator. Some example of image map generators include Adobe's Dreamweaver, Fireworks, and Photoshop. And such software can help you determine the map's coordinates, but all of these cost money, none of them are free. The other option that you have, the alternative, is to use web-based software that determines coordinates of images. And during our lecture last week, I did provide you with a link to one such free service. I believe off the top of my head it was imagemap.net. I'm going to check on that and I'll provide that link for you one more time. It isn't super user friendly, but it works and it's free. So you can use that for your own lab assignment 4. Okay, and that's pretty much all we need to know about image maps. Now we'll move on to the next topic, which is sound. The types of sound available for web pages could include voice, it could include music, could include sound effects. Um, Sound can, in general, help you get ideas across in ways that are not possible with just using text and images. So it can serve a variety of purposes, so to speak. You can convey information. For example, if you click on a word, you can hear it pronounced. You can use it to set the mood. You can capture attention. You can explain a process. You can provide a personal contact. There are two ways of delivering the sound to the end user: downloading and streaming. So the non-streamed version, the downloading version, basically requires that the complete file is first downloaded to the user side, to the browser from the web server, and then it should be played. The streamed version does not have this kind of requirement. It streams the file to the browser, which means the user listens to it in real time as the multimedia data stream arrives in the browser, and the browser doesn't wait for the file to be downloaded completely. YouTube, I guess, is an excellent example of one such example of how streaming works. These are created and saved in two totally different ways. Streaming is more complex for both the server and the browser. We should note that. We want to use streaming when we do things like we present live events, when, for any sound that requires a very large file and cannot be downloaded first. You just don't, you cannot afford to wait for the user to download it and then listen to it. And when you need to save time, so you just basically don't want the user to wait at all. The file formats, there are numerous different file formats that can be used, and these vary from browser to browser and from one version of a browser to the next. Here are some examples: MP3, Vorbis, OGG, MPEG-4 audio, M4A, and the MP3 format, probably the most popular format for storing and delivering audio on the web. It uses a compression algorithm that reduces the file size up to a dozen times, and yet it retains almost the same fidelity. So that's the reason why it's probably the most popular type of audio file. OGG, this sound file format uses a relatively new audio compression format that is comparable to MP3. It's open source and it's free to use. It is popular as an HTML5 format. M4A is just the audio-only MPEG-4 format, and it's supported by QuickTime, iTunes, and iPods and iPads. Helper applications and plugins. Helper applications are programs that can be designated to handle a particular multimedia file type, such as a WAV or an MP3, for example, to allow the user to view or otherwise utilize the special file. The helper application runs in a separate window from the browser. Plugins. Plugins are a more common method. Plugins run in the browser window so that media objects can be integrated directly into the web page. Okay. Complex animations, video, sound, and interactive games require browser plugins or helper programs such as Real Player, QuickTime, or Shockwave Flash in order to display these effects. Flash is used for interactive animated content, Real Player for video and audio, and QuickTime for a variety of video and audio content. And of course, we have Microsoft's Windows Media Player. Okay. Um, a couple of words on interactivity. Um, Okay. Interactivity. Communication of ideas is richer and more effective, but more complex when it's interactive. Older forms of modern mass communication are just one way in nature. The audience have little influence over the experience. Multimedia and the web offer the possibility of presenting interactive communication, which is an interface that visually and audibly responds to viewers' actions, um, and this way it should be easier for them to pick up and understand the content that is being presented. Simple sound files were used on the web since the earliest days. They could be linked to or downloaded like any other file. The drawback was that audio files are relatively large, and this was problematic in the ways of slow internet connections. But as the web developed, some major breakthroughs have been made in terms of the delivery of sound files. Data compression is very important to audio and video on the web. Compression techniques rely on a couple of things. They could be removing repetition, which is, if you recall, what the G format used. They could be based on averaging. An example of that would be the JPEG format, sound and video as well. They could rely on range reduction, for example, of the volume of the sound. Could rely on selectivity, for example, what colors and frequencies and movement um, remains in the data and what gets truncated. Or they could rely on frame difference, and video is an example of this, a very good example. Compression methods. Sound compression codecs are used, which are special software or devices that allow you to compress or decompress sound, and they use some of the methods that I just mentioned: repetition and patterns, averaging, selectivity, range reduction. Um, MP3 actually originated in a scheme to compress soundtracks of films. And codec, by the way, is just an abbreviation for coder decoder. Audio on the web. The simplest way to add audio to a website is to use existing music, sound effects, or other resources. We should be aware of copyright issues, though. It's important. If the audio is copyrighted, then you need to get permission from the copyright owner. To get permission, you usually need to pay licensing fees. The most common browser players for non-streamed audio are QuickTime and Windows Media Player, but there are others, of course. Alternative, we can prepare our own audio. The preparation of original audio requires a number of standard steps. You record the sound, you edit the sound, and then you optimize it for web delivery. Quite a few sound editing software out there on the web. Some of the ones that I can list here off the top of my head: Audacity, Cubase, Pro Tools, SoundForge, Audition. These change, by the way, with time. Some of these may get outdated, not supported anymore. New ones may be introduced, so feel free to look around and pick one that you like and use one for your own. You don't have to actually use one for the purposes of this class. For the exercises in the labs, we can just use audio that we find on the web. But if this is something that you like to add to your own web pages in the future, you probably want to learn how to create audio as well. Oops. Adding sound to a web page. Few ways to do that. What you're seeing here on this slide is you could have a simple link. So we've already done that in the past. It can be an image or it can be some text, and you link it to the audio file, in this case an MP3 file. So it's use the simple anchor HTML element, and the href attribute refers to the audio file. When we do this, however, we have no control over how a user's web browser will play the sound. It might open an external application helper in a new window, such as Real Media Player or Winamp, or play the sound within the browser itself. Embedded sound. It is possible to embed a sound file in a web page so that the sound starts playing automatically when the page loads. Um, some web design purists don't recommend that. The problem with background sounds is that the browser users have to turn the sound off or adjust the volume if they don't like it. And furthermore, background music on a web page is many times unnecessary and may appear as a distraction. Okay. We have started talking about HTML5, but we should not forget about um, syntax that people have used up until now, because this is still supported. You can still program this way. With the previous version of HTML, you could use embed and object. With the new version, embed has been refreshed. It's got a different syntax, and as you already know, we can use audio and video. So um, the embed element, as noted here, was indeed deprecated. They were planning on removing it, but it has been resurrected in a new form in HTML5, and now pretty much all the browsers support it. Oops. Here's the syntax for the embed element. Any HTML embedded sound element causes a sound file to be downloaded into the browser, and then it starts playing. To do this, the browser looks for a plugin player to play the sound file. Internet Explorer will try and use the Windows Media Player plugin. Firefox and other browsers require you to install a suitable plugin such as the QuickTime Player. And it should be noted that sound stops playing when the user leaves the page. The source attribute that you see here identifies the file that is to be played, and it is mandatory. It should be included. The image that you see below this is the default view of the controls. Okay, so by default, the embedded sound plays as soon as the page loads, and also the browser may display a sound controller. The appearance of this default sound controller varies depending on the audio player. Um, for example, QuickTime, Windows Media. So depending on which browser you're using, you're going to get a set of controls that might look slightly differently than this. Okay, the embed element is a non-standard but well-supported element that is used to embed multimedia content in a web page. Um, It has a number of attributes to control how the sound is played. Here's the list of attributes. We should note that the support for some of these, though, is patchy across all the browsers. Let me say a couple of words about a few of these. The source attribute specifies the media file name. The width specifies the width of the media player icon. Height is for the height of the media player icon. Hidden identifies whether to hide the media player or not. Auto start plays the file immediately, and loop plays it immediately. Plays it repeatedly. So these are probably the half a dozen attributes that you are likely to use in your own programming. Visual representation. I thought it would be interesting to include here a couple of examples of how you can turn off the visual representation of the controller. So if you want to use something like JavaScript to create your own controller, it's fairly easy. We can do that as well. The way to turn off the standard controller could be one of the two ways you see here. You could either set the height and the width to 0, or you can turn on the hidden attribute to true. Okay. The object element, you see the syntax here for the object element. It has a number of attributes. Here's a quick example of how we could use that in our code. It illustrates the syntax. And then on the next page, you're going to see the number of attributes that you can use with object. One important attribute is the name of the sound file. That's the data attribute you see up here at the top. Another one is the type attribute, which specifies the type or the format of the sound file. And of course you have the height and the width ones as well. The param element, depending on the media type and plugin or player to be used, additional configuration values are required, and the param HTML element defines runtime settings um, for the multimedia object that is referred to by the object element. Okay. It is nested inside the object element itself, so you're going to need the object tags, and in between them you use the param tags. Here is an example of how to use this. It has been used to set the parameter name and value. There are some issues with these with the param element with Internet Explorer, so keep that in mind. Earlier versions may have problems and you may have to figure out workarounds. Um, Here's an example of how to embed audio using Windows Media Player inside Internet Explorer. It requires the class ID attribute and the param attribute source right here. This HTML that you're seeing right now works for Internet Explorer, does not work for other browsers because it explicitly references the Windows player. It puts the Windows Media Player controller object on the web page. Unless a browser has a Windows Media Player plugin, this HTML will only play in Internet Explorer. It is possible to use the class ID to embed a different kind of player, such as QuickTime. But I'm not sure we want to see that. I don't think we can. I think the OCC office restricts what kinds of players are used on campus. So just keep that in mind. One possible solution actually is to have two different object tags. You create one object tag for Internet Explorer and another one for all the other browsers. And here's a note to that. It is possible to see that quite often. An example. Okay, so here we're telling the browser if you are using if you are Internet Explorer and you're using Windows Media Player, this is the way to do it. And otherwise, here's what I want you to do. Okay. Other people recommend nesting the embed element within the object element. The object element satisfies Internet Explorer, and the embed element satisfies all the other browsers. Okay, so this is like killing two birds with one stone. It solves the same problem as what you see here on the previous slide. The embed element defines any embedded content for a web page. This element was in early versions of HTML. Then it was removed from HTML4. Now there's a revised version in HTML5. You can see the attributes here, along with a link to a more detailed discussion of the embed element. An example of how to use it, you can see this here on the next slide. All right. And here is where I'm going to stop for a couple of minutes, and we will continue in just a few moments.